All right, all right, all right. Here we go. Woo! We got a special guest, two special guests here today. The first one, you may or may not know him. One of my favorites. Whoa! Who is it? Woo! It's R2-D2. Bud, have you ever seen R2-D2 with a lightsaber? Whoa! Yeah. So he never gets a lightsaber because they just know that he would just take everybody out, right? Because he's R2-D2. Woo! Don't give him a lightsaber. Yeah. Thanks for being here. Thanks for watching. Get to our. Oh, that was a good one actually. Ready for this one? Yeah, R2-D2. Nice. So we are looking at 12.4. Quick, easy video, not a very long assignment. So don't forget the problems on the front page are review for our final exam. So good practice. Getting ready for our final exam already. So double check your number one right now. Pause me. Try number one. So basically when you see FG, that actually means F times G. There's a little tiny dot there. So F times G is what they want you to do. So here's F right there. And then x squared minus 4, there's G. And then times means you're going to distribute. So 2x times x squared is 2x cubed. 2x times negative 4 is negative 8x. 3 times x squared is 3x squared, which is a higher power, so we're going to write it in second place. And then last but not least, 3 times negative 4 is negative 12. So really there's our answer, 2x cubed plus 3x squared minus 8x minus 12. Nice. And so number 2, you have to do f of x and h of x, but then you have to plug in a 5, and plug in a 5. So it's f plus h, or h plus f, associated property, doesn't matter the order. Doesn't matter the order there. And then you're going to plug a 5 in for x. Plug a 5 in for x there and there. So we end up with 13 plus radical 19. So do you still remember how to take f of x and plug it into g with problem number 3? Just going to plug it right in there, right? Just going to plug it right in. F into g. Here we go. So we have f, which is 2x plus 3. And it wants you to plug it into g. So x is going to go away, and f will have to be squared. So 2x plus 3. And then it's going to be all squared now, and then minus 4. So here's the all squared, and here's the minus 4. Right? So we have to just plug f right in there in place of the x. Don't times it with the x, in place of the x. In place of the x. Right? And then you're going to multiply that out. I'll let you finish that for homework. So go ahead and distribute it, and don't forget the minus 4 at the end. So distribute, 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 distribute. Cool. And then you go the other way. And so f of g is the same as f of g of x. And that's just taking g, which is x squared minus 4, and plugging it into f, which is 2x plus 3. So taking g of x and just plugging it into f. And so that'll be 2 times x squared minus 4 plus 3. Wait a second. Yeah, plus 3. Distribute the 2. So we get 2x squared minus 8 plus 3, which is just 2x squared minus 5. Way-o. 2x squared minus 5. Cool. So try number 5 on your own. Try number 4 on your own. Don't forget subtraction means to distribute it through. Don't forget to distribute. Don't forget. Don't forget to distribute, guys. Don't forget to distribute. Distribute the negative, invisible negative. Subtraction is invisible negative. You distribute through, right? Distribute through. Nice. Okay, remember how to do these for the test. Well, what's 24 divided by 6? 24 divided by 6 is just 4. Or you could say 4 over 1. Divided by 6, divided by 6. So 4 over 1. And then you have 1 on the bottom and 3x cubed on the top. So One of them on the bottom will cancel, leaving us with just x squared. So what is the square root of 4x squared? It's just going to be the square root of 4 is 2. And you have x squared, which is x minus x. Everything comes out. So just 2x. Way-o. So 2x is the right answer for number 9. Number 9. So don't forget for number 8 to pull out the perfect square. So the perfect square could be like 36 times 2, for example. Or maybe it could be what? 3 times radical 25, for example. Yeah, so it's just like pulling out the perfect square. The highest, the biggest perfect square is what you really want to do there, okay? Pull out the perfect square. With 8, that's a little tricky because, I guess, no, it's 4, right? The square root of 4 times the square root of 2 is the square root of 8. So the square root of 4 is 2, 2 times 3 is 6. There you go. So far, so good. So far, so good. I'll let you finish. I'll let you finish. You got this. Don't forget how to do synthetic division. Your favorite, synthetic division. Remember, it's the opposite sign, though. Opposite sign. Don't forget how to do synthetic division. So we're going to go ahead and do a positive one. A positive one. Upside down house. And then we have an invisible one there. So 1, negative 3, 6, negative 12, and 8. There we go, there we go. Factor all the zeros, right? Factor all the zeros. So we're going to bring down the 1 first. That's the first step. Don't forget to bring down that first term. Bring down the 1. Bring it down. Bring it down. Bring down the 1. So then you multiply, combine it. Multiply, combine it. Multiply, combine it. 1 times 1 is 1. 1 with a negative 3 is a negative 2. 1 with a negative 2 is negative 2. With the 6, so 6 with the negative 2 is 4. Multiply, combine it. Multiply, combine it. Multiply, combine it. Good. And you should get a remainder of 0. And then it's 1 power less. 1 power less. So x to the 3rd power. So x to the 3rd power. So that's going to be right here. So x to the 3rd power is 1 power less. So this will get the x to the 3rd power. And this will get minus 2x squared plus 4x minus 8. Then you're going to draw a line down the middle and pull out the GCF. Remember how to do this. Come on. Do this for the final exam. So x squared times x minus 2. And then pull out a 4, pull out a 4. So we get an x, also minus 2. Way-o. What did we pull out? Oh yeah, we pulled out a what? We pulled out a 4. So we pulled out a positive 4. Good. So then we're left with our factors, which are x minus 2. Don't forget the x squared with the plus 4. That's another factor. And then don't forget the original, which is the x minus 1. So don't forget the original. So there's our x minus 1 there. And now we're just going to go ahead and set each of those, right? So that came from up here, by the way. X minus 1 in parentheses was one of our factors. One of our factors. Cool. So there's our x minus 1 right there. Okay, so then you got to write all the zeros. So this is going to be x equal. Whoopsie daisy. Whoopsie daisy. So this is going to be a x equals positive 2. This is going to be a x equals positive 1. For this one, a little tricky now. You're going to have to x squared plus 4, so it's equal to 0. You're going to have to minus 4 to both sides. So you get x squared equals a negative 4. Then you're going to go ahead and square root both sides. Uh-oh, we got a negative in there. That's going to become 9. So x equals plus or minus. It's going to be a what? Square root of 4 is 2. So the square root of 4 is 2. And the negative becomes an I. Plus or minus 2i. So the answer will be x equals a positive 2i. And x equals a negative 2i. Way-o. So don't forget to do synthetic division. Synthetic division. Yeah, so now we're going to jump to the other side where we're doing intersection. Yeah, intersections, intersections. Well, yeah, KL immortalized. Yeah, KL. Okay, let's see here. So if you're missing a test, come see me after school. Come see me. Get her done. Get her done, get her done. Get caught up with us. Get her done. Wayo. Okay, so number 11 we should have done in class, which I'm sure we did. We got those two answers. So now we'll take a look at number 12 and number 13. So here's the steps. If you were here in class, here's the steps. So step number 1 is solve for y first, right? So for example, for number 11, we had to solve for y first. We had to solve for y first. So what we had, so this one's already solved, check, but this one had to be solved. So 2x minus y equals 5. We had to minus 2x to the other side. Cool. Then there's an invisible negative 1 that we had to divide over. And if you do it on one side, you have to do it completely on the other side every term. So divide by negative, so we can change all the signs. So this becomes a positive y equals a minus 5. And the negative divided by negative is a positive 2x. And then we can rearrange that. We could we could rearrange that and do do the 2x first. Put it there, put the negative 5 there. It's called the associative property. So you can switch those around. And then that's what it looks like. So then we have 2x minus 5 is our y2. And let's say that, let's switch it around. Yeah, we'll say our that's our y2, good. And then our y1, again, our y1 will be the 4e to the x power minus 10. Cool. And then you just plug into your calculator. So we're going to give it a try with number 13 right now. Let's do an odd with you, number 13. So we're going to go to y equals, we're going to, there's our graph already for number 11. So we graphed it in there, right? We went 4 seconds, e to the x power, right arrow, minus what? Minus what? Minus 10. And then we went 2x minus 5, and we graphed it. And then I went to my window, right? So first solve for x, then you plug in your y1 and y2, your equations. Then you're going to hit the window button. And when you hit the window button, hit the window button, you can change your y min, your y maximum. So before I pushed zoom 6, which gave me a 10 by 10 graph, boom. Then I noticed that my intersection was way down there. It's kind of hard to see. So I went to the window and I lowered my y minimum to be like, I don't know, a negative 15 or something. And so then I pushed graph. Oh, you can see it better now. Look at that. You can see it better now. Right? So what do you do next? Then you go, so then you after your window button, then you hit the graph button and hit trace and scroll over. Then you push second trace, option 5. Option 5, intersection. So we're going to show you that now. We traced over. Now we're going to go to second calc. We're going to go to option 5, which is intersect. And we're going to push enter, enter, enter. So we get negative 2.299, which is this guy right here, this guy right here. And then we also got negative 9.598, which rounds up to 0.599 because this rounded up. Rounded up from an 8 up to a 9. Cool. And you can do the other intersection by tracing over. And then do the intersection again. So second calc, option 5, enter, enter, enter. So you have to enter 3 times to do this. So there's our 0.356 and our negative 4.28, which is right here. Cool. Let's try number 13 next. So again, after you hit option 5, you have to enter, hit enter, hit enter. And then it will then show you the intersection. And get your answers. Get your answers. So we go to our calculator now. And now we're going to come over here. Awesome. Keep trying. Keep trying. There it is. Okay, so let's enter that in there. Nope, that's not it. Okay, so we go to y equals. We're going to clear our two graphs. We're going to type in, ready? X to the third power, right arrow, minus, don't do the ouchie negative. No, 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 that's bad, that's bad. Bad, so delete those. Minus 2x squared. So if you're talking about ouchie negative, when would you use the subtraction versus the minus symbol? It would be when you would do this. So this is actually the small minus symbol. Yeah, so this right here, if it's in front, then use ouchie minus symbol. It draws blood. Ah, my finger. There's my fingernail. My finger. There's my hand. What is that? I don't know. Okay, so then your minus symbol, there we go. Cool. So yeah, so down here would be the ouchie negative, and then the x squared, right arrow, plus 3x, and then subtract 1, not minus 1, subtract 1. And then go back up here, we're going to finish. So x cubed minus 2x squared, plus x minus 1, there it is. Cool. So again, that's subtraction, or subtraction at the end, or if it's in front, then you'd use the minus symbol. Okay, let's graph it. Ooh, there's a lot going on there. Let's get our first one, then maybe we'll zoom in on another one. So there's an intersection right here, second calc. There we go. So we go to intersect, enter. Where do we go? Enter, enter, enter. So 2, 1. That's an easy intersection. So 2, 1 is one of our intersections. Little box there on canvas, check. Okay, now we're probably going to trace over and zoom in now, because I see a couple intersections going on there, don't you? Let's try it. So I'm going to go zoom, and I'm going to go zoom in. I'm going to zoom in there. Ooh, you see those? I see 2 more. So I see an intersection here at 0, -1, it looks like. 0, -1. Look how I changed my equation. That is definitely an intersection. We'll do it just in case. Second calc, option 5, intersect, enter, enter, enter. So 0, -1. So 0, -1 is another intersection there. On canvas, check that one. Boom. And then our last one looks like there is one down here. So we'll go second calc, intersection, and we'll enter, and then first curve enter, second curve enter, third curve enter, boom. -1, 5. -1, -5 is another intersection. Are there any more? It just seems like there's so many intersections, right? So many intersections. Let's zoom out and see. So I'm going to go down there. I'm going to zoom out just in case. There shouldn't be, but just in case. You never know. So let's see one there. Let's see one there. Let's see one there. I think we're good. I think we're good with the 3 intersections. That was so many. So we had -1, -5, 0, -1, and 2, 1. Beautiful. So that's how you do it. This is how we do it. This is how we do it. So I'll let you go ahead and keep trying these on your own. So keep practicing. Solve for y first. You try. You try. Solve for y first. So this will be y2, this will be y1. Solve for y first. You try. And then plug it into your calculator. Plug it in your calculator, right? Plug it in your calculator. We'll do double check number 15 for you really fast. And we'll just do one of them. Let's do the other one. Just get the hang of it. So go to y equals and clear. Okay, so now it's going to be the ouchie negative this time. It's in front. Ouchie negative is in front. In front. So use negative symbol. Not negative symbol. Negative symbol, not subtraction. Not subtraction, okay? Not subtraction. So we're going to go ouchie negative 2, parentheses, 4 to the x power, right arrow plus 3, down arrow, we have a 0.5 times, I'll do parentheses just in case, x to the squared, oops, that's not going to work, delete, squared power, and then minus 2x. Okay, give it a try. I'm going to push graph. Ooh, I see 2 intersections. Do you? Yeah, let's go ahead and zoom 6 it. That's our standard 10 by 10 graph, zoom standard. So enter, enter, boom. Okay, so I see 2 intersections there. I see an intersection, second calc, option 5, enter, enter, enter. So -1, comma 2.5. So we have x value is -1, comma 2.5. And so that's going to be, check the box there on canvas. Easy assignment, you love this. Trace over, see if you get it right. So right about there, second calc, trace. Option 5, enter, enter, enter. Boom, that's a crazy one. So that's 0.468. So 0.468, there's a point there, 0.468. As well as, rounds it. Ooh, that's going to round up to -0.827. So that's going to be negative 827. Yep, so 8265, but that rounds it up. So this becomes a 7 is what we got there. Okay, there's our other answer. Woo! Cool. So those are our 2 answers. Way-o. So you try the next one on your own. Try the next one on your own. You got this. You got this. The last one to help you with. In 1992, the average income in dollars for a doctor aged X years will be modeled by this equation, recall. For what ages did the average income for a doctor exceed 250,000? So basically, this is going to be like your Y1. And this is going to be your Y2. 250,000 is like your threshold. And so you're just going to plug this into your calculator. And you're going to find the intersection, right? Find the intersection. Way-o. There we go. So that's your Y1 and Y2. And we'll put please graph it. You might need help because of the crazy window. Okay, I see what I know where you're going with it. Okay, go to the crazy window. Okay, so we'll plug it in there. So first of all, we have 250,000 for Y2. Last one, help you with, you got this. So now we're going to do ouchie negative 425 x squared, right arrow, plus 42,500 x minus, wow, that's a big minus, 761. Okay, so the problem with this, too many zeros. The problem with this is the window, right? The window's got to be huge. So I'm going to push graph and you will not see a thing. So we're going to have to do zoom. What kind of zoom we're going to do? Have you heard the word zoom fit? There's actually a really cool tool there called zoom fit. And so zoom fit tries to fit both equations in there. You see it? That's pretty good. We're not quite to the intersection, but we're getting there. So we go to our window now, and we see how far x max needs to go. So what do you think? Take a guess. Maybe 50? 50? 50 seemed to work. 50 seemed to work. What about our y maximum? Should we go a little bit higher so we see above it? Maybe like 100 or something? Yeah, let's give that a try. That's a little higher. You go higher? Okay, fine. How about 251,000? Why not? Why not? Still can't really see at all that maximum there. So let's try plugging in an extra 10,000, see if that makes a difference or not. I don't know. Okay, boom. Not really. Okay, so we're going to trace that there to see where the threshold, what age, how old was the doctor when they reached 250,000, the threshold there, right about there. Second calc, we're going to go to intersect. We're going to go to enter, enter, enter. Yes? Yep, right about there. So 38.99. So x equals 38.99. Right? Which is about 39 years old. Okay, for what age did the average income for a doctor exceed 250,000? So maybe there's a boundary going on, right? 39 to what? Oh man, you're saying we're going to have to go further? Yep, we're going to have to go further. So our window will probably have to go to maybe 100 years old. And then our Y, let's see, maximum, just to make it look even better, we'll do 300,000. Whoa, that's a lot of money there. Okay, we'll push graph. There it is. You see it? So we're jumping off the charts there. And then we're going all the way down to this intersection about there. So second calc, intersect again, option 5, enter, enter, enter. Okay, about 61 years old. So there's our boundaries, going from 39 to 61 years old. Good job. Thank you. Behind the screen. Woo! Thanks for watching. You only had to do one video on this one. Wayo. Thanks for watching. Bye for now. Bye for now. Thanks for watching. Bye for now. Yeah. Chewbacca, where is he? Is he coming next time? Probably. See you next time, Chewbacca. Yeah, thanks for watching. Bye for now.